All right, let's get started. Hello, everybody, and thank you for joining today's webinar. I'd like to introduce our presenter, Waukesha Product Training Center Manager, Matt Walloch, who's going to present today's topic, ESM1 Help Access. Matt will go through several topics today, so if you have any questions or need him to pause, please use the questions function in the control panel. If you have any technical issues at all, don't hesitate to chat or use that questions panel to speak up so we can assist you. With that, I'm going to turn it over to Matt.
Excellent. Thank you so much, Allie. Really excited to kind of keep this momentum that we've had with our first couple of sessions and build on it with our ESM1 system, or the ESM system, now kind of referred to as ESM1 a lot. So essentially, the white box. This is the one that we're going to be working with today. Now, this series, we are recording it. Again, we'll kind of reinforce a few housekeeping things, just like Allie had referenced. Use the questions feature or the chat feature. We're going to be monitoring that, and we're planning on having some Q&A towards the end of the session. So if there's something that you get interested in and you're like, oh, I wish I knew that, you know, if you got a question right away, you could go ahead and put it in there, and we'll make sure that we address it towards the end of the session. So don't hold on till the end of the session to ask your question. If you have something, or you have something that pops up, go ahead and put that in there. And Allie will make sure that we get those questions asked at the end of the session when we have our Q&A. The other piece of it is that we do have all of the lines muted. So, you know, make sure we get rid of that, you know, going through the drive-through noise or whatever else may be going on with the kids and the dogs in the background. You know, this is our time frame where we meet more this way. So we want to make sure that we get good information and don't get any interruptions as we get through it. So your lines are muted, which is why we ask you to use those question and chat functions. Now, today's session's a little bit different. You know, the first session we kind of said, you know, well, here's a little bit of a teaser about what is eHelp and how do you use it for the different systems. And we kind of went into them both at a fairly good level, but still a little lighter than where I want to go today. One of the other pieces that folks ask us is, you know, tell me how to understand why those faults happen. So we're going to run through a couple of scenarios today of, you know, here's how to kind of take the information that's in your fault log and put a story together, or understand what may have happened that led up to these group of faults or potential shutdowns actually occurring. So we're taking that feedback and we're going to try and work off of that today. But one of the first things that we want to do is kind of find out a little bit more. You know, as we go through, one of the pieces that we know is within that ESP software, there's a lot of little things that are in there. People use, you know, the number one, I'm connecting to an engine, I'm going to get things programmed side of things. But how many of the other things that are in there are you familiar with? So let's launch our first poll here again. You know, as we look at trying to make sure everybody is understanding the material, one of the things that we do is try and use polls or use some of the different cameras and activities so that we keep people engaged. So first one we've got to look at, what pieces of the extra ESM features do you have experience with? Is it related to actually using eHelp? Well, great, that's an important piece. Do you know how to find the documentation or where the manuals are within your ESM folder? Have you used the training tool? A lot of people see a blank screen when they first open that up and they don't really understand how it works. So we're going to try and go through a little bit of that. The last one is understanding Workspaces. And of course, some people, I've clicked on some stuff, not quite sure what it is, or they haven't used it. And that's one of the reasons they're joining us today. So we'll take any of those answers and we'll just give it another minute or two in order for that to kind of close up, give you guys a chance to join in here. All right, as we take a look at our results here, we're going to see about a third of people have used the documentation in the eHelp function. So that's a great thing. You know, knowing that, you know, the training tool, a good number of people have used, and then some of the other pieces, that's great. So today's piece is that we are going to make sure that we go through all of those parts. So this is eHelp, but it's also a little bit of the what else is there within the system. So as I take a look at that, we're going to go and start sharing the screen here. I'm going to show you how I've got things lined up here for when I'm running an ESM training class. Now, the first thing you'll notice is I've pretty much cleaned up my screen so that we just have those 4 icons that we have that get loaded as part of your zip file that you get. Now, the first one that we look at over here at the top left, you're going to see this is the one that says ESM on it, the same as what you would see on your ECU. Now, remember, ESM is that whole system. It incorporates a PDB, it incorporates the ECU, it includes all of the sensors and actuators, as well as the software, ESP. So those are the 3 letters that are down on the bottom here. ESM isn't the box. The box is actually the ECU. So that over here, this is our ECU. That's not an ESM box. It's part of the ESM system. So here we've got our reference for ESP. So when do I use this one? The short answer is anytime you've got an actual engine, anytime you've got one of these white boxes over here, you're going to have it powered up and you're going to want to interface with it. So if you are right next to an engine or if you're next to an ECU that's powered, that's the one that you want to use because this is now going to take the real data that's coming into the ECU and allow you to go and interface with it. It also allows you to make those changes within the programming parameters or those blue boxes most of the time that we're looking at for how to make some programming changes if it's necessary. Don't always just make changes just to see what happens. Make changes when you know kind of what the end result is or that there's a reason for it. Now, as we move over to the opposite side here, so looking kind of at the top here, we see it says ESM as well, but now we've got our little notepad and pencil here. Well, this is the ESP Training Tool. Now, we're going to use that today. And one of the reasons we're going to use the ESP Training Tool is sometimes you're not next to the engine. Sometimes maybe you don't have the right cord. And you still need to try and figure out, based on the flashing lights or a customer that's sitting next to an engine telling you what those flashing lights are telling you for codes, what's actually going on. You can do troubleshooting off of the ESP Training Tool. Now, you can duplicate your screens so that you can make it look just like what that customer is seeing, but I'm going to tell you the secret. This is the fastest way to get into eHelp. If you know what your code is, don't worry about connecting to an ECU. You've already got what the codes are. They're sitting on the front of the ECU. Jump into the training tool and we'll show you how fast it is to jump into the help section and open up the eHelp so that you can work with it. Now we've got the other 2 that are down on the bottom, and the reason I put them down on the bottom is not because they did anything wrong. The reason I put them down onto the bottom is because they're a little bit less used and a little bit less applicable for what we're going to do today. The ESP modem access tool, this is one of those things where a lot of times you're going to have interaction with somebody from a Waukesha group or potentially from one of our distributors. We're saying, you know what, there's something going on within that ECU, and maybe we're going to try and change some of the base code or what we call typing within the ECU. That requires interaction from a factory folks. So we don't allow just anybody to go in there and change the ECU from, say, a VGF over to a 275. That's pretty dramatic. You wouldn't want to do that on a real engine. So we want to have that pretty locked down for who actually can do those sorts of things. The other piece to this was sometimes we would want to kind of watch what's going on within the ECU. Well, back in the day, instead of using what we have now with My Plant, where we can connect via the cloud and whatnot, we've got where we had to have a modem. And there are still modems that we have sitting, for parts use in order to be able to connect up. It was a very early system for trying to hook up and pull some information off of that ECU. Again, nowhere near what we can do with My Plant, but looking at modem technology and how fast that information moved, this was really more so from a service perspective or some early diagnostics work where we would be involved in order to do that. Now, the last one over here down at the bottom is our log file processor. Well, sometimes you're pulling information off of the ECU and we're like, I don't understand what's going on, or you're trying to troubleshoot and you want to find out, when does that fault occur? Well, sometimes you're not able to sit there or you're trying to share that information with someone else. So instead of saying it does this and then it does that, A lot of people want to see the data. So we can actually capture the information coming out of the ECU and turn it into an Excel type file or a spreadsheet type file. Now there's going to be limits for how long you want to run one of these just to make sure that it's something that's readable. But this is a way to pull information from the ECU and get it into more of a report form. So these two on the bottom, we're not going to really focus on for our purposes today. So we're going to focus and connect up with an ECU that we've used actually from our first session related to a VHP engine. So we'll go ahead and open that up now. Now, as I look at this particular one, we're going to see real simple things. As I look here, well, kind of in the center of my screen, but depending on what the profile of, if you've got a different screen type or whatnot, you're going to see you've got this connection here. Now, this is the harness for what we have that comes off of the engine. Now, many of you are familiar with these harnesses. You got your 1-pin connector here that's got the 8 leads coming off of it, and that's going to be what actually goes into your ECU. On the other end, we've got what was called an RS-232 or a DB9, because it's got 9 pins, but you've also got the outside shield or the 10th pin or 10th communication piece for going over to a computer. Now, whose computer still has one of these? Chances are very few of you. Now, there are some of the tough books or the technician level type computers, and they will still have those on there. If you have one, by all means use that, because it is usually going to be the easiest way for the ESP software to work with an ECU. But if you no longer have that, a lot of times you end up using an adapter, and it goes from the RS-232 or the DB9 type connector that you used to have. Some people just call it the 9-pin connector, and use that to go over to a USB connector, which is far more common on most devices. Sometimes there's a little language difference between those two. So we've seen people that have had cables and cords that have worked, and all of a sudden they say, nope, it's not working anymore. Check out that converter. A lot of times there is a driver or software that's used in order to take that 9-pin connector or 9 communication pieces plus the outside ground and transfer that over to a USB, which has 4 pins plus the outside. So 10 pulses to 5 pulses, you need some software in order to figure out how to make that work. A lot of the adapters actually use some good software that you can download either from their site, or some of them still come with a disk or something else that you could use. Now, I'll tell you, my computer doesn't have a disk drive, so I ended up having to get the software direct from the manufacturer in order to make it work again. The other piece that we're looking at that's really important here is there's no alarms. Well, we're trying to do some eHelp training, so that's an important piece that, hey, I know there's no active alarms, but that doesn't mean I'm going to stop troubleshooting. Just because I don't see anything active, that doesn't mean that something didn't cause for the customer to come on out there and give me a call. So I'm going to move over to my F10 status screen, and I'm going to take a look here. It says, okay, yep, no active faults, just like we expected. But let's move into our view faults screen. With these earlier systems, before they had kind of that exit bar, you would go and use this F10 panel in order to get to your faults. Now I look here, and just like I expect, I'm going to see nothing because we saw there were no active faults. But let's find out the rest of the story. I come down to the bottom here, and I'm going to view my total fault history. Now this is one of those stories or scenarios that we're going to try to walk through here. We've got a situation with these top 2 sensors. Now, again, when we look at the number of sensor faults that we're looking at right here, remember, this is a training center ECU, so if we have to mess around with disconnecting this or reconnecting that or putting a sensor underneath the candle, we'll do that in order to replicate what a over temperature or what a loose connection may look like. So a lot of these faults are really us kind of messing around, but I wanted to focus on these 2. This was a story that came in from one of our students that had come through on a class, and they said, I just don't understand what's going on. Well, they said, okay, I've got a high coolant temperature fault that was here, so alarm 333. And then I've also got this alarm 422, and they're one right next to each other, and then I see that the engine shuts down. I'm like, huh. Well, let's take a look at it. Alarm 333, let's move into our fault help. As I move in here, I knew that I was working with a VHP, so I'm going to select that, and I'm going to select my alarm code. I'm going to scroll down here until I get to alarm code 333. You can see mine is purple instead of blue because I was practicing and making sure that I had all of my information together before our session. But normally they'd be all blue, or if you've gone through all of them, they'll turn to purple after a certain amount of time. But this one identifies that we have a high coolant temperature and the engine coolant temperature was too high. Well, I still don't know whether this is my auxiliary circuit or my jacket water circuit, so I'm going to open this up and try to find out. So we get our high coolant temperature. I'm going to open up the little caret here and get my description. It says engine's overheating, and it could potentially shut down in order to prevent engine damage. If the temperature goes so high beyond the alarm range, it would then activate the related ESD or engine shutdown code of 333. We haven't gotten there yet, so let's see what some causes are. Well, these all look pretty straightforward. This identifies that I'm in my auxiliary circuit, so I may have a low coolant temperature for that circuit where we're not able to exchange properly. Might have air locked in it. Again, air doesn't transfer temperature away from those hot metal parts the same as what we would have with liquid. Could be running overloaded, could have some problem with some thermostats. Well, it kind of runs through all of these different scenarios. As I go to the troubleshooting, I get kind of the same thing here. So remedy one, let's check that coolant level. Make sure that you have the right size tank, make sure that it's not open to atmosphere, that we are creating pressure, and that everything's working right. I move through again. Well, this one could be an interesting one. Early systems, or as the engines are manufactured, we leave a petcock, or like you would see on the bottom of a radiator of a car, you've got just kind of this little thread that goes in and out in order to vent things off or allow you to drain things out. We put them at the high points on the engine. Now, in the older manuals, it said, okay, well, you should open and close those once per day to make sure that you don't have any air getting into the system. As years progressed, we realized that's not really practical. So all of our packaging guides have shifted over to say, you know what, we really want a permanent vent line to be installed so that you don't run into this situation of an air pocket getting stuck and then running into overheating of the engine. So if your engine still has petcocks installed on it, this is something you want to talk to with your customer and let them understand that, you know, putting in a permanent vent line that goes below your water level in your expansion tank is a great way to make sure that you don't run into some of these nuisance situations. That's not what we were dealing with in this particular story, but it is a good thing for you to look at. Well, now we look at our static lines or our vent lines, if we do have vent lines installed, or those balance or check lines that are in there to make sure that we have positive pressure. It went into saying, well, let's look at something else. Maybe it could be something related to the cooler or some of the piping. It could be that the fins on the cooler are bent, or we could have just something as simple as a belt slipping. Now, I don't want to hear any stories about people complaining about belts on VHPs today, but we understand that that certainly can happen. Make sure that we get everything properly tensioned and changed. Now, if we look a little bit further, we can see making sure the engine isn't overloaded, checking if it does not have an ESM system that our intake manifold pressure is correct, using some of the brake horsepower to intake manifold predictive spreadsheet. We also would then use potentially some of the inch calc information, but really the ESM engines are going to have overload control built into them. So this hopefully is not what we're running into. We look at making sure we've got everything okay on the radiator, again, moving into the pump and stepping on through how to inspect our thermostats. The auxiliary system uses a blending thermostat, so trying to make sure that you hit your target temperature so that you get your combustion process to work just right. And then lastly, kind of looking at your intake valves. If you run into where those are leaking or not properly sealing up, you can run into higher temperatures within the system, potentially related to the combustion process going on, not where it's designed to happen. All right, so we're going to find that one of the sources is going to be within this group here. I'm not going to skip to the end of the story until we go a little bit further, because I'm going to poll you guys and see if you can figure out what caused it. So let's go back. Let's now look at alarm code 422. Now this one I know we looked at in the first session, but let's jump back to it. So I scroll back down, I find where 422 is, and this now says instead of a temperature issue, I've got a different issue with this cooling circuit. So this isn't related to being outside the range. This is just saying I'm not getting a good reading. I, in this case, ran into the OC or the open circuit, but I could also run into a short circuit. Open circuit is that we're sending out, say, the 5 volts from the control, but we're getting nothing back to communicate. A short circuit would be we're getting almost the entire 5 volts back, saying there's something wrong. Maybe somebody jumpered something out or cross-wired something. Something else may have happened within the sensor, but it's a complete short circuit. We also have signal high and signal low. Well, wait a minute. We had alarm 333 that was related to being over temperature. And now you're telling me that I could also have a signal that was high. Well, that is beyond where the range of where we expect the engine to run in. So let's say again with our 0 to 5 volt expectation, the most we're expecting is say 3.5 volts, and we get a 4. Well, we know it's not a short circuit, and we know it's not an open circuit, but it's beyond what the range of the engine is expecting. So that's a different type of fault. So we have 4 different 422 faults. I come back through, and my troubleshooting completely changes. It's the same circuit, but a different fault. It says, number 1, with the open circuit, we're going to look for loose conditions. We're not looking at belts. We're not looking at coolers. We're actually looking at now the control circuit that's going on. The next one is looking at our connections. Again, if we don't see anything here, we can look for damage both to the B input on the bottom of the ECU or looking at the connections on the sensors themselves. Remedy 3 says between pin A and B, this is a 2-pin sensor. We're going to go and measure the resistance there, and we're going to say, okay, if we're within our correct range, we should see running right around here in this 85, 185 temperature is going to be on the high end, so we should be a little lower than that, reading our resistance on that particular sensor when we're looking at our target temperatures and say 130, 140 degrees, depending on your application. Last one, let's do some pin checks. We know that the pins are coming out of 33 and 39, so again, 10, 20, 33, and then 39. And then here's our A-B connectors on the sensor that we would be doing our continuity tests. So in this instance, I'd be going from pin 33 and following that over to pin B on the plug that goes into the sensor in order to make sure that I have good continuity there. And vice versa between 39 and A to make sure that everything is working properly to try and eliminate those issues. So now we're going to take a look at our situation. Well, I've got a customer. And the customer said, okay, I've got this over temperature. I've got that alarm code 333 going on. And I don't want to get to ESD 333. And when I run into that 333 code, I end up having the engine shut down. So the engine's still running, so I don't believe there's really an issue. I'm going to go ahead and instead of trying to troubleshoot, find out what's actually wrong with this auxiliary cooling circuit or why it says it's moving to too high of a temperature. I don't trust that thing and I'm just going to disconnect it. All right, so now here's your engine quiz. What do you think is going to happen? We've just eliminated the shutdown or the protection from high coolant temperature on the auxiliary circuit. What do you think is going to happen? Go ahead and jump in on the poll here. You think the engine's going to run just fine? Not going to have any effect on the engine's potential power? Do you think the engine will continue to run and have limited power? Or do you think the engine's just going to shut down over a specified amount of time from not getting a signal from the coolant sensor? Give everybody just a few more seconds to jump in here. Looks like everybody's pretty active so far this morning. Appreciate that. All right, looks like most folks have had a chance to jump in here and vote, so I'm just going to go ahead and get that one closed. Now let's share what you guys thought. Well, it says 14% say it's just going to keep running. It's just going to keep doing what it's doing and try and pull that power as long as it can. And a portion of you say, well, it's going to try to run, but it's going to limit the power. We're going to come in there, and Waukesha is going to say, no, you can't do that. And then the majority of you say the engine at some point is going to shut down. Well, let's kind of run through this scenario. Okay, my auxiliary circuit. It's important for my combustion temperature, or what's going into the combustion chamber for my air charge. I want that to be right at a target, and it's going to heat up as it goes across the turbo. So in this scenario, they said, nope, I don't trust your auxiliary cooling sensor. I'm just going to go ahead and disconnect it. Is that going to cause the engine to shut down, going and having that alarm code 422? The answer is no. So some of you that said no, well, it's kind of true at the beginning. Well, then we run a little bit longer. Well, that air charge being hot starts making its way through, and now it starts making its way into my intake manifold. Well, now my intake manifold temperature goes high. And guess what this same customer decides that they're going to do? They say, well, if I can't trust the cooling temperature sensor and the engine's still running, I'm just going to go ahead and disconnect that intake manifold temperature sensor too, because you can't trust those sensors, those newfangled computers. They just don't know what they're doing. So he does that as well. Well, now what's the effect? Well, now my air temperature has gotten so high that my risk of detonation has kind of gone through the roof. Well, guess what happens then? Engine starts detonating, doing what it's supposed to do, and the detonation sensors are now trying to bring it back. Now, this is where we get into the second scenario where it says engine's still running, but it's on limited power, because as it goes to limited power, it starts delaying our timing slowly to try and take it out of that detonation situation. Well, progressively, as we start reading more and more of those detonation sensors, we start saying, hey, detonating, and we get to a point where the temperature is just so hot that it's uncontrollable, and you'll reach an uncontrollable detonation limit, and the engine will shut down. Well, guess what our trusting customer decided to do? They decided that they were going to disconnect the detonation sensors. So what started as really a cooling issue, they've now turned into a detonation issue. Well, when they disconnect the detonation sensors, we don't have that feedback loop. So the detonation sensor allows us to kind of run right up to the edge. Ask anybody who's built engines or tries to figure out how to make the most power on them. When do you make the most power? Right when you're on that limit, right when you're sitting there on the edge of detonation that you're going to potentially destroy the engine. That's where you make your most power. Well, how do you put a control system in order to get close to the edge but not fall off of the cliff? That's where the detonation sensors come in. When we start seeing that the detonation sensors are going to start coming in and correcting what's going on here, the next piece is I have to delay my timing. I have to go to a safe place where I know I can run, but not where I'm going to risk detonation. And guess what happens to our exhaust temperatures? Yeah, we're not able to use all that power. So we end up where we run into situation number 3. So the engine will run. It's going to give you all your alarm codes and say, hey, I ran over temp. You say, I'm going to pull that one off. Okay, now I'm not communicating with that sensor. So you've got 2 warnings in there. Well, now you run into intake manifold temperature being high. Well, pull that sensor off too. Now I got 2 more. One that I'm over temperature and another one that I've actually got a disconnected sensor. Now I've got a 3rd fault that's going to say that I'm running into detonation. Pull all of those sensors off. So I've got a whole slew of sensor faults that say that they're disconnected. And now our end scenario, customer ends up complaining about the life of their cylinder heads. Because as we delayed the timing so far, their head temperature went through the roof. We protected the engine as far as we could from having uncontrolled detonation, but we did it at the risk of, we know the cylinder head is going to take kind of the brunt of it in order to make the engine last. So in order to make the power, we put detonation sensors in there. We put temperature sensors in there. We put pressure sensors in there. They're there to make sure that we can make that power on varying fuels and all the varying conditions that we have to run in. Now, the end of the story. Why did we talk about this so long? And Matt ran through this whole scenario of a coolant temperature. Turned out there was something wrong with one of the valves, not on the engine. Somebody during maintenance had opened a valve in order to allow all of the coolant to drain out of the auxiliary system. As they refilled it, they had that valve open so that they could feed it in from the bottom and fill up to the top. When they went to restart the engine, they did not move that valve back over so that it was exchanging the fluid through the cooler. So here we have a scenario of something that was very simple, a coolant temperature sensor that was saying, I've got a problem, not understanding how to follow through the troubleshooting tree or what would have caused that to run to that high coolant temperature, then led them to going down a bad path. And they went down the bad path of figuring out, hey, if I just keep disconnecting sensors, I can keep the engine running. But then they ended up with a much more costly repair and then figuring out all they had to do was open up that valve. So hopefully this was a worthwhile kind of troubleshooting exercise here. Kind of the same as what we've done in past presentations. We really do appreciate everybody joining in and making some time with us. So our next poll we're going to launch is, who's joining us today? How many people do we got out over the cyber waves joining in order to find out a little bit more about ESM1 E-help? We'll give everybody just another minute or two to get their information in there. Again, thank you so much for everybody that's joining and making some time. Also, thanks to those of you that are treating this as a little bit of a group training. So all good stuff there. And again, thank you so much for making some time to learn a little bit more about the Waukesha engines today. So kind of our majority of folks are sitting there with one person in the room, completely understandable. We each have our own devices. And again, thanks to those of you that are treating this as more of a group training, and hopefully you'll be able to make use out of this for the future. Again, we've pounded on it, I think, in each one of the sessions. We think the information is pretty important. You can continue to share your registration link. So send from the very first post, whether you found them on LinkedIn or got them from a colleague, send that link to somebody else so that they can register, and then they will have access to be able to watch the sessions. Remember, each one of the 4 sessions has its own registration. So if you want to grab all 4, you would register 4 times. And we're not closing the registrations down. So again, if somebody you think would really benefit from watching some of these materials, please send them the registration link so that they can join in and take a look at some of the stuff that we're trying to do today. Now, if I take a look here, I'm going to close out here, and I want to do something that's really important, and I'm going to speak from my own faults on this one. If I look up here, I go to File, and I can hit Exit, or I can just hit the X box over in the corner here. But this is a really important thing. Now, I've run into this in classes. I've been out working on the VGF in the back of the shop and showing people how things are working. And we come from our VGF SE that's out there, and I disconnect, and I come into the classroom and I reconnect. What just happened is a bit of a problem. I just disconnected from a VGF serialized ECU, and it tells me I'm working in a certain workspace. If I want to know what my workspace is, I can actually cheat and look up at the top here. It says currently I'm working in workspace HLXO. That's important if you're using the training tool for somebody to know. And it gives all my ECU and engine serial numbers as well as the calibration that I'm working on. So all your information is here, as well as in this F10 panel, your version details would pop up. But that's not why I'm giving you this tip. What I had happen is I left where I was in the engine room, and came into the classroom. And when I came into the classroom, I tried to connect to this workspace in ECU. And it said, no, you can't do that. I'm still trying to connect to that VGF. So they built into the software that if you lose a connection, or you're walking away and your laptop unplugs from the ECU because you forgot it was connected, it's got where it's going to say, I'm going to try to reconnect. I'm going to try to reconnect. And it kind of saves that in the background. Now, some of you may have run into this one where all of a sudden you're going to a site and it says, okay, I'll reconnect. But you look in your program files and it lists 2, 3, 4 active ESM ESP sessions. Well, each one of those is for an ECU that you disconnected from but didn't close out the right way. This can cause a bit of a nightmare when you're trying to upgrade your software, because it says, no, I can't upgrade. I'm currently attached to another engine. Even though you're sitting in your IT department, your guy's going, yeah, there's nothing here. You have to close out each of those individual sessions before it would allow you to update your software. So the way to prevent that, go in here, hit File and Exit. In the center of the screen, you're going to see some pistons pop up, and they're going to say that it is shutting down the proper way, closing out of that ECU. It's actually collecting then a snapshot of your last settings and saving that to your local device. So here we get our little pistons and fan moving there, and now I've properly closed out. So that's a good step. Everything's good there. That's what we want to see happen. The next one that we're going to move into is our ESP Training Tool. So as I open that up here, this is where a lot of people run into problems. They say, well, what the heck is this training me? Well, it's not training you anything because you haven't selected anything yet. Now, because this isn't how eHelp works, I'm going to do you the quick favor and say, all I want you to do when you open the training tool, if you're unable to connect to an engine, or it's too loud, too warm, too cold, whatever it may be, hit this and hit your help contents. That's the quickest and easiest way to jump into eHelp. You're then going to select which engine you're working on and which codes you're going to be playing around with and trying to do your troubleshooting off of it. But I want to focus a little bit over here on the top left. It gives me my information for my contents. So it gives me an introduction. It also gives me a how to use. So nice little feature. If you can't watch this video, this is a great way to kind of jump in there or get a refresher. It goes into our faults. Well, what stuff do we have for shutdowns as well as our alarm codes? And then it gets into these P codes and power distribution pieces. We're going to dive into that a little bit later. We also get some safety information and our glossary. Now, the glossary is pretty powerful. I will tell you, when I first started here, of all the 3-letter acronyms I had to learn, whether it was ESM and ESP and AFR, I was lost. Well, if I would have known that I had this handy glossary here, I probably would have done things a little bit faster. Or some of the things that we talk about with dithering. Well, what the heck is that? Well, when we have a stepper control engine, we allow it to kind of move back and forth to try and make sure that we adjust with the fuel, or hopefully guess where the fuel is moving to try and improve the emissions on the engine. Well, now you kind of know a little bit more. But these all kind of relate within the ESM systems for where that glossary is. If I move over to the index, that's going to be very similar, where it gives me things related to my air temperature or all of my alarm codes. And then as I scroll down, I'm going to move into my ESD codes. So if I click on one of these, it's the same idea. So what did we have? 333 before. As I open that, it says it's my high coolant temp and how to troubleshoot through that. So I can jump in if I just have a code and be able to go through there. There's also a search function that's in here, and one of the things I always think is handy is a print function, so that if I can't be connected to my laptop, and move back and forth, I can still print out the troubleshooting tree, or if I wanted to, I could PDF this and send it off to a customer or a technician that was in need of a little bit of troubleshooting help. Of course, you got your backwards and forwards navigation that's through here, but that's really under the contents. One of the pieces that I wanted to look at is not just the glossary, but also the alarm codes, shutdown codes, P codes, and then power distribution pieces. So let's take a look here, and I'm going to close up my glossary here. When do we use P codes? Well, this was that add-on function. So anytime I see one of these, when I see that I've got the silver box, if this is a 275 GL Plus, I've always got one of these. The Plus was the NOx system. So that means that I've got an NCM or a NOx control module. We also had with our AFR2 engines, so ESM with AFR2, so white box, but with this as well, the AFR2 engines, so our VHPs from roughly 2014 to 2017, as well as those VGF-SE engines, they use this module as an emissions control module, or ECM. For those of you that are looking for kind of the oddball or the trivia question out there, for our APG 1000 engines, we also use this for the fuel control system, or an FCM. So if you see one of these silver boxes, there's going to be another HMI, whether it's a 5-button or an 8-button. Well, out of this module, it has its own fault codes, whether that's for a stepper or an emission system. But we didn't want the numbers to be the same as what came out of the ECU, because these codes can't send back to the ECU. They live within this box. So we created P codes that you would access through that HMI in order to do the troubleshooting of components that are connected there. So as I open this up, it gives me your 3 engines that you would choose from. So our AFR2 engines, our 275 GL Plus engines, or those APG 1000. The engine or the driver was known as the 16V 150 LTD. I'm going to open this one up here. And they're called P codes because every one of them relates or starts with a P. As I kind of scroll on through here, you can see that there's pieces related to catalysts. There's pieces related to the fuel system. Well, within AFR2, that's really what the ECM was used for. Now, in this case, I'm just going to pick the code P1068. It says this is my post-catalyst O2 sensor, has got a high range. It says the default on the display, that's why I actually chose this one, is going to display 0.455 volts. Well, I'm hoping that some of these eHelp sessions are triggering you to say, you know what, maybe I want to learn a little bit more about the ESM and ESM2 engines. And we do run a full week class for ESM. These are just kind of some highlights from them. One of the things that we have is if you have a sensor that goes dead, it's going to go ahead and trigger a fault, but it's also then going to display a default value. So if you were looking and you saw 0.455 volts, you might say, well, it's reading something. Well, there's a fault that's active, and this is the default instead of just reading a 0 that it puts in there. So in this installation, it says, you know, go ahead and make sure all your connections are good. Make sure that if you're in a safe running condition, safe speed and load, go ahead and adjust the fuel valve so that it moves rich or lean. First go rich, then go lean, and see if the voltage moves. If the voltage doesn't move, well, now we've got something else going on with that sensor or the circuits. So now we start troubleshooting through the harnesses and the connectors themselves to figure out where our failure point may be. So very similar to what we saw for the other sensors, but really identifying, hey, let's make sure that the sensor is actually operating first before we start diving into troubleshooting the sensors themselves. So I think this is a pretty powerful piece for you to know that this is in there, but it was not part of some of the earlier systems. The P codes only came out when we start seeing the 275 GL Plus come out roughly in 2009, 2010. The AFR2 engines in that 2014 timeframe, and a little bit after that with the VGF-SEs. And then we see where the APG 1000 used it in that early 2008, 2009 timeframe, where we see that that system comes into play. Now, as we come on through here, this is a pretty good idea. But what about if I want to replicate what the customer has seen? I'm going to come over here to File, and I'm going to choose to open a workspace. Now, our engine that we looked at before would have been in our centennial. So up in the top, it said the 100th anniversary for Waukesha. When I'm looking at the later developed engines, they're all going to end with this OX44FC6077. That's going to be our horsepower logo that we're going to see as we open this one up. The next thing is I'm going to look in here and I would find what workspace I wanted and open that up. In this case, I want to open up that VGF SE that we have in the back of our shop, which I know is workspace FFKM. It says over here, this is VGF 6-cylinder. Because I'm in the training tool, it doesn't give me any of the information at the top here. I don't have a real engine that I'm connected to, so I have no workspace identified there. It says the engine is most certainly in an alarm and I am not connected. We try to make this communication clear that, hey, you're not going to be able to troubleshoot this engine because nothing's moving, nothing's running. Make sure you have to move out of the training tool. So why do we have this? Well, it allows us to help guide people through where do I need to look for the different components. Well, what we did before is in F10, we said, okay, well, that's where our fault is. Not in this one. This is one of those later developed engines like we saw with the 275, where the view faults is down on the bottom. Now we also see manual actuator calibrations and some different pieces for being able to start and stop editing and moving around. But for our purposes, we've got our view fault screen that's here. Now, of course, I'm not going to find any faults. If I pull this up, it actually pulls my last ECU that I connected to. So if you look, here's our instance from before where we had a high coolant temp and the open circuit. And then that allows me to move into eHelp. So in some ways, it's easier to just move into help and help contents and jump right in rather than using the exit down on the bottom in the training tool. I can go ahead and pull my VGF, and we looked at our P codes. But then the other one that we wanted to look at is the power distribution box. Within the power distribution box, remember, we've got the ones that have that series of lights that are in there. Well, when should they be on and when should they be off? In this case, it says LED 1 should be off when the ECU is calling to crank the engine starter. It should be on when it is actually cranking. So here's our quick little troubleshooting to understand how to do that, and if necessary, how to go through the reset procedure for this PDB. Your earlier ones where you just have terminal strips, you wouldn't have PDB troubleshooting. So this only comes into play once we have the LEDs on the PDB. Remember, we're only working with the ESM1 pieces of things. Remember, with ESM2, we don't have any lights in there. Everything is on the HMI. So just make sure that you understand we're working just with the ESM1 pieces for what we're looking at today. So as I step out of this, this is kind of your use of the training tool. I like using it. I like using it for quick access to eHelp. I like using it so that I can prepare before I go to a site. I see over here in this icon right below F4, F5, where I see that horsepower logo. Again, the horsepower logo is something that dates back to the 30s here in Waukesha, so pretty cool story. For those of you that may want to hear about it another time, I'll be sure to share it with you. So now we're on to the next step. I want to look at another one of these stories and scenarios. So I'm going to switch over to a different ECU. I'm going to pop in to ESP again because I've got another ECU that I've connected to. And as I open that up, we can see right here I've got version 06R. That's going to be an important piece for you to pay attention to a little bit later. Well, this one is also our horsepower logo. Look, I've got all kinds of faults here, the same as what I had in my training tool, but it does show that I am connected. The reason I have all these faults, I don't have any sensors connected to this ECU, so I should see all of these things active or yellow warnings that are on there. So now it's back to looking at our faults. Now, if I hit my view faults down in the lower exit bar, it's going to pull up a different batch of faults than what we had before because this ECU doesn't have any of the circuits or any of the sensors connected. So all of my alarms are OCs. But I want to run through a little scenario with you, a little story that we got. And I'm going to bring up a new engine. Customer goes ahead and they say, okay, engine's ready to go. Let's fire it off. They start the engine, everything's running good, running good, running good. And then they see it. Now, right over here, this little jumper that goes between the cylinder head and where the water manifold carries things back over to the thermostats. We go and we have right in here a little gasket that's in there. And the engine all of a sudden gets a little drip, little leak coming out of it. And I'm like, okay, well, who knows who put that together, when that happened, did they do it right? Can't do anything, just got to fix it. So they go and they clear some of the space out there so that they can go ahead and get the work done. And they go and they restart the engine. Okay, everything's good. But then they see high intake manifold temperature. We didn't have that before. The engine was running just fine. We ran into a high intake manifold temperature, and then pretty soon the engine shuts itself down. That seems weird. So they let it cool down. They go through their books. They go through all their codes. They're like, okay, high intake manifold temperature could be related to this or that or whatever it may be. Well, let's restart it. They go and they restart it. Everything seems to be running fine. And then sure enough, that temperature sensor comes back again. What do you guys think was the source for the shutdown on the engine? Was it something related to a sensor? Somebody knocked something over or disconnected it? Do you think there was something wrong with the ECU? Maybe somebody put in something wrong. Was it related to the harness? Something just got tripped over or disconnected? Did they mess with the fuel system setup and that's what led to your incorrect fuel setting? Or was it related to the insulation around the exhaust? Give everybody another second or two to take a look at this. All right, we'll close this one up and share everything with everybody. Well, I think some of you may have come through an ESM class once or twice before because I know we've been telling this story for a while. As I take a look here, this is our 275 as it goes through production. So it's kind of a cool little look of what it looks like. Well, if we look here, this is my exhaust manifold carrying my flow over to the turbo and then out through the exhaust. And here's where I've got my water manifold as we take a look at that. And as I look at it, one of the things that I see is there's no insulation around here. The 275 GL Plus switched from a liquid-cooled exhaust to an air-cooled exhaust. So as I go back and forth to my picture here, all of this stainless steel was removed, which is very important to carrying the heat away from our intake manifold. So the 275 is a little different from our other engines where the intake manifold and the exhaust both exit the engine out of the center of the V. So if you don't have this insulation on there, you can actually run into high intake manifold temperature. So this is just kind of a quick one, but some good guesses out there between the harness connections and whatnot. Turned out in this instance, it was actually just related to the insulation not being reinstalled on it. So coming back out of this, I'm going to close through here and exit properly out of my ECU. And now we're going to get to those promised things that we talked about that we wanted to share with you as well. What I'm going to do now is show you how to find the manuals. Very quick process. As you go into your hard drive, so your C drive on your device, you're then going to move over to your program files. If you have two folders like I do, program files and program files x86, that identifies that this is a 32-bit machine. I want you to go into the x86 file. You're then going to find where your ESM folder is. Go ahead and double click on that. As we look at it now, I'm going to come into my documentation. And once we get into the documentation, this is your manual location. So all of your ESM1, again, white box engines, have the manuals, not in entirely complete format, but pretty doggone close. Between some of the previous versions, there were some edits that were pretty much shrunk down to nothing. They've put back almost the entire piece. They've also put some of the different diagrams in here for you to reference for the engines themselves. So really good information for you to have, and it's part of your download. The last one here is your training tool. You say, well, what the heck is this thing? I know what the training tool looks like. not so fast. As I open up this text file, as you'll recall, I knew that with the horsepower logo for my VGF SE, I wanted workspace FFKO. So when I'm searching for where am I trying to duplicate what the customer has, this is a super important piece for you to take a look at. So OX44FC6077, that is my horsepower logo, so up on the top. And then FFKO is going to be related to my VGF SE. On that older Centennial version, that's going to be in a different group, and we said that we had that HLXO, which was an engine that didn't have an air-fuel ratio control. So you can find out what workspaces you want to use. So those are two extra little cheats that we wanted to make sure we showed you how to find within your ESP loaded software. So that kind of wraps things for my presentation part of things. I'm going to launch a little piece here to ask who's looking to join us next time. We're going to do a very similar piece where we go through the ESM2 materials. And as we go through those ESM2 materials, we're going to show how to search for different materials, how to maybe look for a user, and then really how to use some of the graphing feature to help guide you through what may have happened right before that fault happened. Maybe somebody changed a setting. How do you find that stuff out? So thanks again for those of you that were able to join us today. Looking forward to having folks join us again in about a week. So we'll go ahead and stop the screen sharing and get a little bit fuller screen. And then we'll kind of open things up. Looks like we had a few questions that did come in during the session. I know we're running pretty close to the end. But Allie, if you would, take it over and see what we can get answered here.
I'm going to open this up here for you guys. Let's see. Got a request to talk about 9394 GSI power loading. So above 90% load, exhaust temp reached more than 700 degrees Celsius, saw red turbocharger oily crankcase. Can you talk about that?
So 9394, I'm going to assume that we're working on ESM1 based engines. And some of the calculation that you get where it says that you're running at 90% load. Now, there are factors that come into play that will limit how far the engine can go. Some of it's related to the fuel that you're running on. So when we have fuels that are a lower WKI or higher BTU or have more volatiles in them, we will say, you know what, we're too close to a risk of detonation, so we wouldn't allow the engine to go all the way. The other pieces that come into it related to temperatures. So what are the ambient temperatures that you're dealing with? There is a sensor on the 9394s that measures your atmospheric temperature, atmospheric pressure, and atmospheric humidity. So there's a trican sensor that's put into the inlet of the engine so that it can tell what are the atmospheric conditions that we're running in. If the inlet air temperature is too high, it can also limit the engine for how much it would allow it to load, because again, it's trying to protect it from that detonation feature. You may also see that your timing is going to shift related to that as well. So just keep that in mind, that when we say it won't go all the way to 100, it's usually that the control is limiting it based on those atmospheric or fuel conditions that people are running into, or potential that the detonation sensor is saying, you know, even though it's programmed right, or our regular fuel and air temperature D rates don't come into play, we may be detonating and it's going to move into a safe place. So there may be more to it. I'm certainly welcome to take that one offline, but also would recommend calling in through our tech services group. They're pretty awesome at being able to look at whether it's a log file or getting a little bit more detail so that we can get you a long-term solution rather than you know, me kind of guessing at things or hoping I get you in the right direction.
Great. I do have another question that came in. why, let's see, let me read this. Why do harness connectors sometimes need to be cleaned on the 275 GL Plus?
I wish I could say that harnesses were going to be perfect. I will attribute a lot of harness failures just to the environment. You know, our harness connectors are supposed to live in an environment that's constantly vibrating. And some of it's corrosive, but usually we're trying to use a connector that's a little bit stronger than that. What can happen, and I have seen this a number of times. Matter of fact, I'm going to go and grab a prop. As we look at, say, a connector like this, so something that could go onto the side of the PDB or whatnot, we run into a situation where the pin sizes that are in here are based on what amount of load or how much amperage or voltage that we're running on and calculating what size pin do we need. So they're not all the same size. Some harnesses they are, but a good portion of them, they're not the correct size. And there's a little recommendation that we give folks, and it's actually to make a mark on the side of the connector so that as you come in here, there's different tabs. If you get the tabs lined up really well, you'll get it on and you'll twist the lock on here and it'll pull it in the rest of the way in order to engage the pins into the socket connections. If you don't do that and you're just clicking around and poking around, you can end up where one of the larger pins goes into one of the smaller sockets. Well, once it's open, you can't fix that. You'd have to actually replace the pin or replace that part of the harness in order to get it to correct, because it's always going to be a loose connection. The other piece that we can find is where the pin will actually kind of push back. That's one where you can try to bring that back in. But a lot of times we see where it's just from misalignment or trying to force the connector on. So make a mark on the outside. That way you can get your alignment and then tighten your lock in. The last one is really related to use of dielectric grease or other pieces within the connectors. That can actually cause an issue as well. We actually recommend against using different greases or lubricants in here. You know, sometimes people think it's going to be helpful, but as you're looking for that pin and then the socket to have a good connection, it actually creates a barrier between the two. And dielectric grease isn't meant to conduct, it's meant to separate or trying to get rid of any moisture within the connection. So you see people that just sit there and they load the whole thing full of grease and then they put the connector together. Over time, that can cause for a loose connection. So those are just a couple of the things that I know and that we've run into quite a few times. I know we're over on our time, so I'll continue to take questions if Allie has any more. But if any of you need to drop off, I certainly understand and hope to see you in our next session. But go ahead, Allie.
Yep, no, I think we have just a few individual questions where we'll reach out directly to some folks with some issues that they're having. But thanks very much for the questions that were asked. If you guys have any, feel free to send them in to the email that you received the invitation from, and Matt and team can answer or point the question in the right direction to our tech services team, etc.
Excellent. Thanks again for making some time to join with us. We look forward to having you in our next session. You know, take a look whether you see some materials that you're interested in us trying to develop for our next series of sessions. So thanks again for making some time and look forward to seeing everybody else in our next session very soon.